Hello, ladies, gentlemen, biddlers of all ages. My name is Riley. I am the Director of Integrations Engineering for Quai Network, and today I'll be talking to you about how to multiply developer impact and speed for global adoption. And so really what that boils down to, it's a lot of fancy words to say as developers, we can do more in less time with better tools. So I'm going to talk to you a little bit today about how we at Quai Network have kind of approached our building to tools and how we hope the industry as a whole moves towards building tools for their users. So first, let me talk a little bit about Quai Network to help you understand what it is that we are trying to build for when we design our tool set. So first, Quai Network is a scalable, programmable, proof of work blockchain network. Okay, we are a monolithic network, meaning that there are not L2s built on top of us, but instead, we actually incorporate horizontal sharding into a hierarchy of merged mined blockchains in order to do our scaling. Okay, and so what this means from a technical perspective is that we have a sharded address and execution space that we are taking into account when building on Quai Network. Okay, so that actually ends up being a pretty good bit of complexity for the user from an outside perspective. Okay, in addition to that architecture, Quai Network actually is a two-token system. We have Quai, which is a gas token, which kind of applies to the saving model, meaning it is intended to be deflationary over time. And Quai operates within the Quai ledger. Okay, this is an EVM or account-based ledger. Our second token, which we call colloquially the energy dollar, is called Qi. Okay, Qi actually operates in a totally separate ledger from Quai. They still maintain, or they're co-located within shards, you can say. So for every shard, we do have both a Quai ledger and a Qi ledger. Okay, but Qi is a UTXO-based ledger. It is not an account-based ledger similar to Quai. This does kind of make it a bit of a fragmented experience from the outside. So this actually means our tooling has a lot of work to do to unify this experience for developers, okay? So we kind of have this philosophy that we abide by, and I think this is generally applicable to other blockchain networks, but even beyond blockchain network systems in general, okay? And the philosophy is the greater the complexity of the system, the better the tools must be. Okay, and so if we can put it into an example, if we have system A and system B, system A has a very high level of complexity, system B has, let's say, an average level of complexity. In order for a developer to do the same amount in the same time on system A and system B, the tool set for system A must be better. Okay, this is a very simple principle, but it actually does matter quite a bit when considering the complexity of your system and how you're going to approach building its tools. So let me talk a little bit about how we actually philosophize these design principles. Okay, we kind of want to take a first principles approach to building our tools. And so our main philosophy is for any user, we want to reduce their cognitive load or their cognitive burden associated with operating within our network. Okay, so really as a developer, whenever I try to build something or interact with any system, I have an intention of what it is that I want to do. Anything ancillary to that intention is cognitive load. Okay, if I have to consider something that is not helping me execute upon my intention, that is additional overhead that I should not really have to consider. So let's talk about how we actually tackle this problem in Quai Network. So like I mentioned a few slides ago, we are a hierarchy of merged mined blockchains with a sharded address and execution space with 2 ledgers per shard, EVM, UTXO. As a developer, if I just want to send an EVM transaction, if I just want to send Quai from me to someone else, that's a lot of additional things to consider that is outside of my intention. My intention being that I just want to send Quai, okay? So what we do is we actually say, let's just let them focus on the intention. let's make sure that our tool set handles the complexity of this multi-sharded environment, handles the complexity of deriving addresses that are valid in shard, handle the complexity of routing requests to the proper shard in the first place. Okay, the complexity actually grows when you think that as a node or a miner, I don't have to actually provide data or mine for the entire network. I can take a slice, okay? We call them slice nodes. And a slice node is starting at the highest level chain, which we call prime. We can actually go back just a few slides to help envision this. Okay, so there are 3 levels in the hierarchy: are prime, region, and zone. Zones are, we could think of as any L2 or an L1. This is the chain that I, as a user, am interacting with. If I want to send Quai, I will direct my transaction to one of these zones. The higher level chains are actually to orchestrate state transfer across the zones. Okay, so let's think about this in an actual concrete example. So if I am in zone 1 and I want to send a transaction from zone 2, or to zone 2, let's imagine these 2 zones are co-located in the same region. Okay, if I want to make a transaction from zone 1 to zone 2, the region chain for that region will help orchestrate that state transfer. If I want to send a transaction from, let's say, zone 1 to zone 5 might be in a different region. Well, in this case, we're actually going to use the prime chain to orchestrate that transfer, okay, that state transition there. So there's quite a bit going on here, but me as a user, I only care about sending on zone 1 to zone 2. I don't care about any of the state transfer. I don't care about this hierarchy. I just want to do my intent. Okay, so let's go right back here. So that goes back to this cognitive load. Don't think about prime. Don't think about region. Don't think about any of this sort of trustless bridging. All you have to do is provide an address that's valid in zone 2, which someone will supply for you, and just the value. And the tooling handles the rest. Okay, so our tooling in this case is called Quai's, or the Quai's JavaScript SDK. That is our primary dedicated tool set that I'm going to be referencing here quite a bit. So our next philosophy is actually reduce the number of steps to complete a task. Let's just go back to this same example. I, the user, just want to send funds. It might even be within the same zone. Just another user in the same zone as me. I just want to send them Quai. Well, let's think about the steps required to do that. Okay, first I need to supply the to address, the value I want to send. I need to estimate gas. I need to get a gas price. I need to know how many transactions that I've sent so I can set my nonce. I need to make sure I set my chain ID, right? And this is, just to send this sort of very basic transaction, you kind of get up to, almost double-digit steps. And this is the most basic form of transaction there is. Okay, so what does it mean to reduce steps? And let's go back to what I was talking about with developer intent. If I'm a developer and my intent is to send value, I just want to provide my value to send and who I want to send it to. The rest should be done for me. I don't care about estimating gas. For the most part, let's say on average, the average user doesn't want to set these things. It should be set for me under the hood. And then if we start talking about Qi, the complexities continue to grow. Okay, so with Qi, not only is it a UTXO-based ledger, similar to how Bitcoin operates, but it is strictly denominated, very similar to how you might think about actual physical cash. Okay, and that's how we designed Qi, was to be electronic cash. We want you to spend Qi. Okay, and so the reason we do this is both for privacy and to make sure that you cannot differentiate between denominations. Okay, so like a 5Qi denomination is a 5Qi denomination. It is not scriptable. It is not non-fungible in any way, shape, or form. It is strictly to be transferred. However, you run into a problem when you're trying to spend several of these denominations. Not a problem necessarily, but an extra set of complexity. Okay, let's imagine you're at the store, you want to pay for something that costs $13. Okay, you might have a $20 bill, that'll cover it. You might have 5 or 3 5s, and those 3 5s would also cover it, but the change you get back will differ. And an additional set of complexity within Qi is that it actually enforces address non-reuse per transaction. What does that mean? Well, address non-reuse means that for every output within a transaction, there must be a unique address. Okay, so the way UTXOs work, we're not going to go into a whole workshop here, but just for any curiosity, you have transaction inputs, you have transaction outputs. And in the Bitcoin world, you might only have one output that goes to the recipient you want to send. These outputs can be of arbitrary value. It can be 0.025 Bitcoin. It can be 1 million Bitcoin. Does not care. Okay, but you can imagine if we go back to that example I just gave you, where you're at a grocery store and you're spending these inputs. If I have 3 5s, they go out as 3 inputs. And then I need to get $2 back, in this case Qi. I need to get 2 1 Qi denominations back in the outputs. Okay, you can imagine this change-making problem begins to balloon after a long period of time. Users have to manage all these addresses. Users have to care about how many addresses you give them in order for them to properly map it to the output. Okay, so we're going to get into that, how we solve that in just a second. But as you can see, like I mentioned, these complexities continue to balloon. So what we need to do is we need to say to the developer, you only need to do 2 things effectively. You need to sync, AKA find all of your UTXOs that you can spend across all of the addresses you know about. And then you also need to just send the value. This should be a very simple interface for developers. It should be me expressing my intention through your interface. And my intention here is I just want to send Qi. I don't care about the complexities that happen under the hood. I just want to send it, right? And that's exactly what we do. The interface for sending Qi is exactly the same as the interface for sending Quai. There is no difference, right? And that is because we want users to feel familiar when using this product. The next thing, and this actually builds on how we implemented Qi, is in your toolset you want to be opinionated, but you don't want to limit. So what does it mean to be opinionated as offer a product that is opinionated? Well, when you offer a product, the default case or the easiest path is effectively your opinion on how the user should use the product. Okay? And in my understanding of the opinion of how a user should use your product, that means it should be the most optimal case for how your user wants to use it, or in the case of maybe a public network, it should be the most optimal use of this network. Okay, and so with Qi, like I mentioned, there has to be a unique address per transaction output. This means that even if I were to just want to send you 5 Qi, let's imagine, for example, I have 5 1 Qi denominations. So I'm effectively going to pay you, each one of those 1 Qis 5 times. Okay, rather than me saying, hey, I need you to actually supply me with 5 addresses so that I can send you these 5 Qi, we've actually come up with a solution that is much more elegant and better at preserving privacy for the user. That's our opinion. That's optimal both for the network and for the user. What the solution looks like is by effectively having a single payment code. Your payment code is effectively your identifier. You could be thought of as almost one single address, but we can use some fancy cryptography. It's called elliptic curve Diffie-Hellman, which effectively says, if you provide me this payment code, I can derive addresses for you. And then I can give you my payment code, and you can then derive those exact same addresses that I just derived. Okay, so what this means is we're not passing around, dozens of addresses every time we want to send a transaction to anyone. All I have to do is get your payment code. I can derive your addresses, right? And there is one sort of hop on information exchange, but that can be handled through smart contracts and done very seamlessly. So that is our opinion of the best solution. And of course, like I said, not limiting. Users can opt out of that solution. They can go through the effort and the additional time to maybe make a worse solution. But again, it would not be optimal, but we are not forcing you into a box to do it. And last, complement existing workflows. This one feels obvious. Okay, if a user goes about their day or goes about their work in a specific pattern, don't disrupt that. Find out where you fit into their workflow and build according to that. Okay, and so how we did this is we actually said, we have all this complexity, but we don't want a user to learn another library. They already have ethers, and they have VM, and they have WAGMI, right? And the list goes on. So we're like, let's just fork ethers. Let's get all of that complexity forced under the hood, and let's give them an interface they're familiar with. You don't have to go learn a new tool again. All you have to do is just use a different library, same interfaces, all new functionality. So these are about the tools of today. Let's talk a little bit about the tools of tomorrow. So we believe the tools of tomorrow make you build things that are more decentralized, right? If I'm building something on a blockchain network, chances are I care about decentralization. Why should I have to worry about Etherscan to get contract ABIs? Why should I have to worry about Infura being the only provider of data? Okay, and these are not attacks on these. These are fantastic services, but in our industry, it's don't trust, verify. But we're putting a lot of trust into these people. So for data providers, for example, I'm going to ask for some information about the blockchain state. You're going to respond, and I'm just going to trust you. But there's no reason you can't lie to me. Okay, so we actually invented this thing called NepoPows, or non-interactive proofs of proof of work. And what NepoPows are specifically meant to do is allow you to verify the data you receive on-chain is correct. We build this directly into the SDK. So the default path is now this means any node can be a data provider. Okay, this means that the SDK can route you to a decentralized set of nodes and validate that the answer they give you is true. Okay, this is actually a very sort of big deal in our industry because we have these very centralized roadblocks, and this is how we break out. And the next big thing is uploading IPFS or utilizing sort of a decentralized data storage network for storing contract ABIs. Okay, so this is another thing that we've actually already done. It's in production, and it's a standard we've created so that when you upload a contract, you first upload the ABI to IPFS, you receive a content hash, and you append that to the bytecode in the contract. That means if I have a contract address on Quai Network, I can get the bytecode, I can parse out the IPFS content hash, and then I can just grab the ABI directly from IPFS, and I can know how to work with any contract on chain. No centralized providers needed. The next thing is, we all know we're in the AI era here, of course. Everything is AI, from agents to developer tools to the music we're listening to right now, right? And so what does it mean to build a system and tools that are ready for the AI era? Well, number one's pretty simple. Just make your content and your docs indexable. Okay, this is actually something that a lot of companies get wrong, right? So imagine, you're using some very sophisticated, very JavaScript heavy, fancy graphics for a doc site. It's actually very hard to web crawl that, right? And it's going to be hard for an AI to actually use that information and embed it into the prompt for it to be able to give you a good response, right? And so in order for us to empower developers, I'm not sure how many of you guys are using tools like Windsurf or Cursor or Replit or these tools that are helping us build, but it is imperative to use these tools correctly, you must have correct docs that are indexable by the tools. Okay, so these are low-hanging fruit, but the next one is actually preparing for the world where agents are doing the work. Okay, what does that look like? How do you integrate with that? Well, first of all, there's several actually kind of crypto-native AI frameworks. We've integrated with a few, but there's also really easy things you can do with NPCs to be able to kind of provide tools or common workflows to these AI agents. Okay, so they can say, well, if I have the Quai tool and you ask me to send Quai to you, I can just very easily use the SDK to be able to send Quai without having to worry about it, right? And this is only going to get more popular. We're only going to see more developers using these tools, more AI agents performing these tasks. So the next generation tool set needs to be built with AI in mind, and we're absolutely applying this and building with it every day. So I think we're right up here against time, but thank you all for listening here. I think there's a lot of work to be done. As a developer and as a builder, I know that we are only as good as our tools, and our tools have to continually be getting better until we fall, or else we fall into sort of a legacy system here. But I think we all know that's not where we are. So again, thanks everyone. I appreciate the time. Again, my name's Riley with Quai Network. Please come visit our booth, 521. There's plenty more to learn, and we're happy to talk about it. Thanks.